Okay, so we've got the 2024 OCR GCSE Computer Science Paper 2 in front of me. I'm going to do a walk and talk through this paper, trying to explain my reasoning and decisions behind my answers, and also trying to do this in 60 minutes or less, which might be a bit of a challenge. Just to quickly point out, like I do in most videos, there's 80 marks in a GCSE Computer Science paper, and the time allowed is 1 hour 30 minutes. So 90 minutes for 80 marks, which is approximately 1 mark per minute, leaving you with roughly 10 minutes at the end if you follow that principle. Okay, let's make a start. Now, usually the first page of any GCSE paper, particularly on the OCR exam board, they like to give you like a nice start, a nice settler. And it's no different here this time. We're presented with advice that we should spend approximately 50 minutes on this section. I'm going to try and do it in 40 or less. So here goes. Tick one box in each row to identify the programming construct where each keyword is used. Now, there's 3 programming constructs that we use. One is called selection, one is iteration, and the other one is called sequence or sequencing. Now, sequence is the order in which we do things and making sure that the things we do are in a logical order. So, for example, when you get dressed in the morning, hopefully you put your trousers on after you've put your underwear on. Otherwise, you're going to look like a Superman imposter. And in programs, obviously, when you're writing a program, you want to make sure that you do things in the right way. Otherwise, things aren't necessarily going to turn out the way that you intended. For example, if you ask for an input and then you print a statement, and then you ask for another input after that print statement, and you needed the second input to be printed in the first, it won't work. Okay, so selection, that's where we choose whether things will happen or not. And iteration is about loops and things repeating. And there's 2 types of iteration. You've got count controlled iteration, which is where you do it X number of times. And you've got condition controlled iteration, where you do something while a statement is either true or false. So for example, while raining, put up your umbrella. So we've got a keyword if. So if it is raining, you could put up an umbrella, but that implies that you would only do it once. So that's not iteration, that would be selection. Whereas for and while are both examples of loops, particularly that you might be familiar with in regards to Python programming language. For I in range, for example, will do something I number of times, and you specify the minimum and maximum boundaries. So that's a form of iteration. And while loops, I just gave you the example of while raining, keep your umbrella up. That would be an example of iteration as well. So quite a nice start for 3 relatively simple, easy marks. We're then presented with an algorithm question in the form of a flowchart. Now, the flowcharts are relatively straightforward. There's a couple of things that you need to be aware of and a couple of things that you need to be familiar with and understand before you start these. And you can find this by looking at the specification. I've got a printed copy of the spec here. You've got 5 shapes that you need to know about. So you've got process, which is a rectangle, input and output, which is a parallelogram, decisions, which are a diamond shape, subprograms, which are a rectangle with a kind of border on each side, and the terminal, which is both start and stop, or start and end, which is like a paracetamol kind of shape. And then we've got lines with arrows as well. So they're the symbols that you need to know and understand how to use if you're presented with a question that requires you to either interpret or draw a flowchart. So I'm just going to start by drawing some lines here. Okay, because all flowcharts should link to an end point. Okay. The first one we're met with is an input. Now, I just showed you the shapes that are required there. And when you've got an input or an output, the shape that you're required or expected to use is a parallelogram. So nice, easy start, input, parallelogram, input number inside the parallelogram. So I'm going to draw an arrow after to point to the next instruction. Now, I'm not a big fan of what OCR have done here, because they're saying if num, which is obviously the variable that was input previously, mod 2 is equal to 0. Now, hopefully this is going to make sense why I've done this in a second. I'm just going to put 2 equals 0 underneath there, like that. Now what this is saying is if you've got a number and you divide it by 2 and it leaves 0 remainder, so mod, which is short for modulo or modulus, what this does is this gives you the remainder of any division as the answer. So for example, if you did 7 mod 2, 7 divided by 2 is 3.5, but if you did 7 mod 2, the answer would be 1. And the reason the answer would be 1 is because 7 divided by 2 is 3.5. Now what mod does is mod ignores the integer part of the answer and focuses on the 0.5 remainder. And if we work out how many times, well sorry, if we do 2 times 3 going into 7, that's 6, and we've got 1 remaining. So the remainder of 1 is what mod would return. Okay, so what that tells us is if we divide a number by 2 using the modulo operator and it gives us a remainder of 1, that tells us that it's an odd number. Because if we did say 6 mod 2, then the remainder would be 0, which means that it's an even number. Okay, so yeah, hopefully that makes sense. So I've just rewritten their statement slightly so that I can draw the right shape around here. And the right shape for a decision should be a diamond, as I just showed you on the specification printout. And when I did this with my class, I did point out that perhaps they could have formatted it slightly better there. Okay, we've got an arrow going down to another shape, which is output even. So remember, inputs and outputs always are parallelogram shapes. So I'm just going to draw a wonky rectangle as I call it. Okay, doesn't have to be perfect, but it does have to be obvious what you meant or what you intended. And then we've got this other one over here, which is output odd. So I'm going to draw another parallelogram here. Yeah, that one's gone a little bit awry, sorry. Again, you don't get marks for artistic impression. It's just for the accuracy and whether you've understood the rules of flowcharts. So what we need is another arrow coming from our decision. And we need another arrow coming from here, but I'm not going to finish this one off just yet. So let's take a look at what we've got so far. So input num, if num mod 2 is equal to 0, so if it leaves a remainder of 0, the next thing says output even. So what I'm going to do here is label this as true. You could also say yes. But what I'm saying there is if num divided by 2 leaves a remainder of 0, if that's true, then output even, which means this one obviously should be labelled as false because that's going to output odd. Okay, nothing else appears to need to be done here. So all I'm going to do is join my output false result with the end of my flowchart there. Okay, and that should be that flowchart finished. The mark scheme, you get 1 mark for parallelograms. So 1 mark for the parallelogram times 3. Excuse me. The second mark is for having the diamond decision shape correctly. The third mark is for labelling true or false correctly. And the fourth mark, you can see it's out of 4 down here. The fourth mark is for using arrows to join your shape from start to end. And that includes this one here. Some of my students in a mock exam recently missed this connector here. So nice start there, 7 fairly easy marks available. State what is meant by the term syntax error. Give one example of a syntax error in a program. Okay, well, you've got 2 types of errors in programming. You've got a logic error, which is where your maths or your logic doesn't quite make sense. And you've got a syntax error, which is where the rules of the programming language are broken. Now, there's another consequence of breaking the rules of the programming language. In a language like Python, for example, it won't actually execute your code. So I'm just going to have an arrow here saying stopping the program from executing. I could say running, but I'm going to say executing, because running is something you tend to do outside when you're trying to get fit. Okay, so stopping the program from executing. Give an example. If I put print, but I missed out the T at the end. So if I put prin, brackets, speech marks, hello, speech marks, and close the brackets, I'm just going to say misspelled keyword. Okay, and there are others you could, I mean, I could have, for example, not closed the brackets and spelt print correctly. I could have missed a speech mark, things like that. You know, not indenting after a colon, for example, in Python. So quite a nice, easy 2 marks there. So added to our previous 7, that should be 9 out of 9. A student writes an algorithm to input 2 numbers and add them together to create a total. Sounds easy enough. If the total is between 10 and 20 inclusive, that's important. So 10 and 20 inclusive, then success is output. If the total is if the total is not between 10 and 20 inclusive, then warning is output. So let's see what we're dealing with here. Num1 equals input, enter a number. Num2 equals input, enter a number. Total equals num1 plus num1. We've got 2 separate inputs on line 1 and 2, but we're only adding num1 together. So there's my first question mark. If total is greater than or equal to 10, then print success. Okay, if we come back up to what the question stated, if the total is between 10 and 20 inclusive, then success is output. And what we've got here is if the total is greater than or equal to 10. So there's no inclusive, there's no inclusion of numbers up to and including 20. This would carry on past 20. So that potentially could be wrong as well. Print success, else print warning. Yeah, so it must be line 3 and 4 that are incorrect. Has to be. Okay, so how would we fix line 3? Well, we've got num1 and num1, so I think that's just meant to say total equals num1 plus num2. Otherwise, why have you asked for 2 separate inputs on the first 2 lines? Line number 4, correction. So if total is greater than or equal to 10, so that's okay to start with. So if total is greater or equal to 10, but we missed out the and 20 bit. So I'm going to say and less than or equal to 20. Yeah. So it's that bit there that's missing, or was missing, wasn't it? So it's that bit there. Okay. And then if I just underline num2 as well, just to prove what I changed. Okay, so another 4 marks, and I reckon we've started with 13 out of 13. What I would always recommend is trying to get to section B, which we're a long way from at the moment, with almost all of your lives intact, almost full marks, because section B is where you will come across some slightly more difficult questions. And if you can get there with a grade 6 already in your pocket, then you're not going to stress yourself out with what people perceive as more difficult questions. Show how a binary search will be used to find the number 10 in the following data set. Okay, now here's how a binary search works. We start by finding the middle value. Okay, so finding the mid. Okay, I'll put a value there. 2, we compare that mid to our target value, okay, which in this case is 10. So show how a binary search will be used to find the number 10 in the following data set. So I'm going to have an arrow here. Okay, so 6 is our middle and 10 is our target. Okay. Now I don't need to write those bullet points. I could just write them here instead. So start by finding the middle value. I'm going to call it the middle. Okay, bracket 6. Compare value bracket 6 to target value, which we now understand to be 10. 6 is less than 10. So disregard 6 and all lower values. Okay, and that will leave us now with a new list, and our new list will just be 7, 10 and 20. Okay, so if we then find the middle value, that's going to be 10, which means we found. So find new middle of new list, which is 10, search over, because that's only worth 3 marks. If it was worth 4 or 5, I probably would have added a little bit more to my description here. You know, I could have said compare new middle to target, for example, but it's only worth 3 marks, and I think we've done enough to hit those 3 marks there. State one prerequisite for a binary search algorithm. So a prerequisite is something that needs to happen in order for something else to happen. So if you go into a restaurant and order food, one of the conditions of that is you need to have money to pay for the food. If you don't have the money, you're going to have to roll up your sleeves and wash the dishes to pay for your meal. Now, what you'll notice about those numbers is 1, 2, 5, 6, 7, 10, 20. They were in order. So I'm going to put numbers. Now, there could also be words. So I'm going to say numbers / values must be in order. You could say ordered, you could say sequence, you could say any of those sort of similar meaning words. So we had 13, 16, 17 out of 17, I reckon, so far, and we've not really troubled ourselves too much. Tick one box to identify the name of the sorting algorithm that splits data into individual items before recombining them in order. Okay, so if we've got let's say 2, 1, 8, 7. Yeah, there are individual numbers. Now let's say that they're grouped as a pair and they're grouped as a pair. In order to order them, we have to split them up first so that we can deal with them individually. So 1 would be on its own, 2 would be on its own, 1 would be on its own, 8 would be on its own, and 7 would be on its own. So we've now separated or split the data into individual items before recombining them in order. So 1 and 2 would switch places, and 7 and 8 would switch places. Okay, and then potentially 1, 2, 7, 8. We'd then box those as a new list. And what I've just drawn there, because we are splitting them before merging them together, it's known as a merge sort. So that was really, really easy. I probably over-explained that for a 1 mark question. Okay, we've got a program that allows users to search for and watch videos. Users give a rating to the videos they watch. Identify one input and one output for the program. So this searching for and watching videos, users give a rating. So the input could be the rating that they give the film. So ratings given to the film. Or the name of the film that they're searching for or something like that. The output would be the film itself. So the film that they're actually watching. So streaming. Although that's probably not important because it's not asking about RAM at the moment. So another 2 marks and I reckon we're at 20 out of 20. So far, nothing too tricky, nothing too difficult with this 2024 paper 2, which they did warn us beforehand, by the way, would be easier than the year previous, but that's because the year previous people really lost their stuff over the 2023 paper 2. Describe one method of defensive design that can be used when creating the program. Okay, so I'll first look at something that might require us to step outside of our comfort zone. Defensive design is about how we anticipate as programmers how somebody else might misuse our program or do something that we didn't expect them to do. But a good programmer should always expect somebody that's using their program to potentially make a mistake or cause a problem. So defensive design, one method could be restricting erroneous data input. Yeah, so restricting erroneous data input. Now, how could we do that? How would we stop someone from making a mistake that we didn't want them to, that potentially could cause a problem with our program? Well, one way of doing that is to use something like data validation. Okay, so I'm going to say by using data validation. Okay, now you could, so in the example above, so e.g. restricting ratings to 0, 1, 2, 3, 4 or 5 stars only. Yeah, so they can't just say, oh, the film was all right, the film was okay, because it wants a star rating. So 0, 1, 2, 3, 4, 5 stars would be the best way of doing that. I'm just going to turn the flash on here because it's getting rather dark when I'm recording this. No, it won't let me do that now. So 2 marks, that should be 22. Truth tables. I quite like these questions because they're a nice way to pick up a number of marks relatively easily. So what we've got here is a statement, P equals A and B or C. So P equals A and B or C. Now what this would look like if you drew it as a diagram would be the inputs A, B, C, P being the output over here, and we've got brackets around A and B. So that means that in my teaching, I always tell my students to do that bit first. Okay, so you've got an AND gate with the 2 inputs A and B. We've then got a C input, which is joining up with the output of this through an OR gate. So an OR gate should be like a slightly curved back with a slightly pointed front, something like that. And then join those 2 together. And then that becomes the output P. So you've got an AND gate and an OR gate. Okay, now that's not what this question is actually asking you to do though. Complete the truth table for P equals A and B or C. So what we're looking for is where A and B are both 1. So on this one it's a no, this one it's a no, this one it's a no. In fact, it's a no until we get down to these bottom 2 values. Sorry, these bottom 2 rows, I should say. So P is on, or P is true, or P is 1, when both A and B are both 1. Okay, so I can immediately put a 1 in this cell, and I can immediately put a 1 in this cell. Or where C is also 1. Oh, sorry, I say where C is also 1. I should say where C is alternatively 1 if A and B were not both 1. So this would also be a 1 here. This would be a 1 here. And this will be a 1 here, because what you'll notice is C is 1, C is 1, C is 1, so P is also 1. So P is basically 1 if A and B are 1, both of them at the same time, or if C is 1. Any other condition is going to be a 0. So 0 in there, 0 in there, 0 in there, 4 very easy marks. Thank you very much. Draw a logic circuit for P equals not A and B or C. So not A and B or C. So I just said a minute ago, didn't I, that when you draw these, anything that is in brackets, typically we do it first. We approach that bit first. So B or C. So let's have an OR gate there. There we go. By the way, the examiners are told to ignore if you write the name in the shape. It's actually about the shape itself that's important. Because I could draw a box, for example, and say that that's an AND gate. I've understood it, but this question is seeing whether I remember how to use the shapes correctly. It's not assessing my understanding. This question was doing that. Okay, so you have to use the right shapes. Can't stress that enough. So not A and B or C, not A. So that's easy because we're going to have a NOT gate, which is a triangle with a little nipple on the end, coming out of A. And then the output of these 2 is going to join through an AND gate, which is like a capital D. Okay, and then that will output to P. So you've got a not A and B or C, which we did first. So always do the bit in brackets first, and there's a nice easy 3 marks again. So What did we finish with on that page? 22, 26, 29. 29, we've probably got a grade 3 already, but we're not even halfway through the paper yet. Okay, the variable message is assigned a value. Message equals A, B, C, D, 1, 2, 3, 4. A, B, C, D, 1, 2, 3, 4. So 8 characters, okay. Print message dot length, output 8. So they've done the first one for us. They've done the first example there for us. Print message dot upper. So dot upper will take whatever the message was and turn it to upper case or capitals. So that's quite easy because the letters will just be capital A, B, C, D. And the numbers obviously don't have capital equivalents, so they just remain the same. So capital A, B, C, D, 1, 2, 3, 4 would be your answer there. And then print message dot left brackets 4. Now it doesn't say message dot upper left 4, so I'm going to assume that we're going back to the original, which is lowercase. So message dot left, and then the 4 left characters would be A, B, C, D. So A, B, C, D in lowercase is what they're looking for there. Fourth one, print int. So that's important because it's telling us it's going to be an integer. Message dot right 4. So the 4 right characters, let's underline those, 1, 2, 3, 4, multiplied by 2. So 1, 2, 3, 4 multiplied by 2. 1, 2, 3, 4 multiplied by 2. But the int there tells us that it's a number that's multiplied by 2. So 1, 2, 3, 4 multiplied by 2 will be 2, 4, 6, 8. What some students did on recent mock exams at my school was they put 1, 2, 3, 4, 1, 2, 3, 4 because they thought that they were printing the message twice. But that wouldn't be true if with int there. If you didn't have int there, then I would understand why they did that, because you're printing a string twice. So another 3 marks there. What did I say? 29, and we're on 32 already, my favourite number. So definitely a grade 3 by now. Write an algorithm in pseudocode to store hello in the variable word 1, store everyone in the variable word 2, concatenate, that means join them together, word 1 and word 2 to store hello everyone in the variable message. So we don't even have to print anything. This is easy. All you do is word 1 equals the message or string hello. That's quite simple. Word 2 equals the message or string everyone. And then concatenate word 1 and word 2 to store hello everyone in the variable message. So I'm going to say message equals word 1 plus word 2. And it's the plus there that does the joining together. Another 3 easy marks, 35. We're probably approaching a grade 4, and I think we're nearly at the halfway stage. Okay, programs can be written in high-level languages or low-level languages. Give 2 reasons why some programs are written in a low-level language. So low-level language is basically binary or machine code or assembly language. Okay, and the reason that some programs are written in a low-level language is because they're easier to, they're not easier to translate. They don't need to be translated. So I'm going to say don't need to be translated, because like I'm talking to you in English now, if English is your first language, you don't need an interpreter or a translator to understand me. If I was talking Italian right now, you'd need somebody who understood Italian and English to explain what I'm saying to you. So that's the first reason. A consequence of that is that the execution of the program would be faster. So you could say faster execution of the program. But also, one of the reasons for writing code in low-level language is so that you can directly manipulate the hardware. And that's why this is quite an undervalued skill, because if you can write code in such a way as that, then you're going to be able to directly control the hardware of the computer, particularly the memory or CPU. Describe the benefits of using a compiler instead of an interpreter when writing a program. So why are you going to use a compiler over an interpreter? One of the things that a compiler does is it can optimize the code. Okay, so it could or can optimize the code. Okay. What else can it do? An interpreter is what we use when we write Python code. So it would line by line read what you're doing. A compiler wouldn't do that. A compiler would basically read the entire code and then tell you at the end whether there were any issues. So I'm going to say it would list, oh, I missed out a letter there. It would list all errors at the end of the failed compilation attempt. I'm just trying to think of a third thing to say here. Oh, I know. Compilers, when you compile a program, what they produce at the end is an exe file. So it produces an exe file, a .exe file, I should have said. So I should have said produces a .exe file. An exe stands for executable. So basically, you could, after you've done that, you could have like a little desktop icon that would run that program for you again and again. So I think we've got all 3 marks there. That's the first one I've got a question mark about, but I'm going to say we've got all 3. That one we've got 2, so I reckon we're on 40 out of 40 now before we approach section B. How are we doing for time? Right, we're okay. An algorithm stores the position of a character on a straight line as an integer, right? A user can move the character left or right. So I'm thinking about Scratch. Those of you that have done any Scratch programming, you've got your X and Y axis, and if you're going that way, it's normally plus, and if you're going that way, it's normally minus, and the same with the Y axis as well. So the following algorithm generates one random number between 1 and 512 inclusive to store as the position, prompts the user to input a direction to move left or right, and then takes a direction as input until a valid direction is input. So P equals random 1 to 512, that's fine. Print the position is P, that's fine. A is a blank string. While A is not equal to left and A is not equal to right, A equals input, so they have to keep doing it. Okay. Describe 2 ways to improve the maintainability of the algorithm. Right, so it's the maintainability that they want to know about here. And when you're writing programs that are maintainable, that is basically how easily understood they can be by somebody else that might pick up your program code later on. So one of the ways to improve your accessibility would be to use comments to explain your code, or at least the important parts. So let's say the significant, because you don't have to put a comment on every single line, the significant lines of code. Now I said lines, I probably should have said subprograms, but I don't think you're going to be penalised for that. What else could I use? I noticed they use P and A as their variable names, so use more descriptive or meaningful variable names. I laugh when looking at Roy Keane's Instagram when he has a photo with his children on there, usually individually, him and one of his children, and he refers to them as child 1, child 2, child 3, and so on. Now, typically what your parents will do is give you a name that means something to them or the family, depending on your gender and things like that. So yeah, using variable names that mean something help others to identify them or their purpose in your code. I'm not sure if I needed to go into that much detail there, but there we go. And comments. So I think describe 2 ways. I probably need a little bit more. So I could say something like example, comment, direction, input. There we go. And that would go like on line direction input. I should say validation there, shouldn't I? So direction input validation, which would be this while loop here. Yeah, so line 4 and 5. Okay. So I don't know if I need to do that, but potentially put that up there. Okay. So probably all 4 marks, although I've got a feeling in the last 2 questions there's a chance I could have dropped 1. But let's say we've got all 4 and that we're on 44 now, which should definitely be at least a grade 4, if not a grade 5. I will talk about the grade boundaries for last year's paper in just a moment. Okay, the second part of this question says if the character moves left, then 5 is subtracted from the position. If the character moves right, then 5 is added to the position. So going back to this diagram here, right is +5, left is -5. Okay. The position of the character can only be between 1 and 512 inclusive. So what that means is that the position here is probably 1, like the boundary of the world or the environment, and the boundary here would be 512. So if the input or the position of the character is less than 1, then it needs to be reset to 1. So sets the position to 1 if the new position is less than 1. Sets the position to 512 if the new position is greater than 512. So you can't go too far left, you can't go too far right. And then returns the new position. Complete the function move character, and we've got that's already started for us there. Now it's important that where they've already started the code, we don't go changing things. So for example, the variable names are direction and position. We have to use those variable names. That's important because they're the parameters that are being passed into this subprogram. So I'm going to say, let's start, it needs to be indented, of course, because it's a function. So I'm going to say if position, what should we say, is equal to left. So if they input the word left, yeah, then, so our next line needs to be indented a little bit further. Position, don't be lazy, don't write P or POS, equals position. And it's if it's left, then it's -5, isn't it? Yeah. And then you could say, go back to the same level of indentation, else if position equals, or sorry, is equal to right, then same level of indentation as the previous position being amended, position equals position plus 5. There we go. Okay, so that's the first 2 done. So it changes the position based on direction, takes the direction left and right and current position as parameters. That was already handled for us, so that was already done. Sets the position to 1 if the new position is less than 1. Okay, so we've got to think about this a little bit more now. So it's going to be a new if statement. I'm going to leave a line deliberately. If position is less than 1, then, and all we're going to say is position equals 1. I think that would be correct. Yeah, don't need to overthink it. And then you could say else if position is greater than 512, then position is set to 512 again, because you can't go further or higher than that. And then there you go, handled those 2, and then returns the new position. So really easy. Same level as indentation as our first if statement. Return, what are we returning? Position. Sorry, I just stumbled there because the question says returns the new position. Now there's 6 marks available there. I can only really think of 5 ways to get the marks, and I don't off the top of my head remember exactly the mark scheme. But I know there's 1 mark for returning the position, because a function should always return a value. I think there's 1 mark each for these, so that'd be 1, 2, 3. 1 mark each for these, 4, 5. Oh, I said it at the start, didn't I? I think it was don't change these. Okay, so don't change variable names. Okay, you have to use them. So I'm going to say use / don't change the variable names. And there's 6. So what do we have? 44 on the previous page. We're on 50 now. That's at least a grade 5. And we're just about to start section B. So section B, it says, we recommend that you spend approximately 40 minutes on this section. Some questions require you to respond using either the OCR exam reference language or pseudocode, or a high-level programming language that you've studied, for example, Python. These are clearly shown where required. So students take part in a sports day. Students are put into teams, and students can gain points depending on their result and the year group that they're in. The points are added to the team score, and the team with the most points at the end of sports day wins. Data about the teams and students is stored in a sports day program. Identify the most appropriate data type for each variable used by the program. Each data type must be different, so you can't use the same one twice. So we've got team name, super team in speech marks. That's easy, isn't it? Anything in speech marks is going to be a string. Don't overthink that. Student year group, they're in year 11. 11 is a number, so that's going to be an integer. And javelin throw, 18.2, that's a decimal. Now, you probably would get away with saying decimal here, but you should really be aware of float or real data types, or even single or double, depending on the programming language that you're familiar with. So string for a word, integer for a number, whole number, and float for a decimal number. Nice, easy 3, 53 marks. Thank you very much. That should be a grade 6 by now. Student names for a team are stored in an array with the identifier the team. An example of this data is shown in the array below. Ali, Eve, Ling, Nina, Sarah, Tom. Right, they're in alphabetical order. A linear search function is used to find whether a student's in the team. Interesting that they're alphabetical, but it's a linear search because linear search doesn't need the data to be alphabetical. But a binary search, of course, requires it, as we said earlier. The function takes a student name as a parameter, returns the value true if the student name is in the array, and it returns false if the student name is not in the array. And we've got the function already started, so function linear search, taking a parameter student name. For count equals 0 to something. Now, a for loop will execute the stated number of times, okay? So if you say for count equals 0 to 3, it will execute 0, 1, 2, 3 times, actually 4 times, because zero indexed arrays, it will iterate one more time than you think. So 0, 2, what this loop needs to do is it needs to check every position in the array at least once. And there's 6 names in the array, but it's 0 indexed, so the last index is actually 5. So what we're going to do is we're going to say for count equals 0 to 5. You also could have said the team length, but I'm not going to use that because if you do that, you need to take 1 away from the team length because the team length is actually 6 and you don't want it to iterate 6 times because actually that's 7 times because the first one is 0, 0, 1, 2, 3. Yeah, I'm just going to say 0 to 5. If the team, now I don't know if you can see this, but these are square brackets. If the team square brackets, so this is where we're looking for an index, okay? We're looking for ideally a number inside those square brackets. So if I said name, yeah, so my name's Daniel. If I said name square brackets 0, that would, if I said print name square brackets 0, that would print capital D, okay? Because D is the first letter of my name. If I changed that and I said name square brackets 1, then it would print A, okay? So name square brackets 1 would print the lowercase a. So if the team something is equal to something, then return something. Ah, right, okay, so we go back to the question. It returns true if the student name is in the array. So it returns true if the student name is in the array. So let's say true student name, and then we just need to work out what is missing here. That probably should be a capital N because it's capital N up there. So if the team index, so the position, is equal to student name. Now the position, you might think you need to put a number there. But if you go back to the line before, our loop, it's for count equals 0 to 5. Now when I write for loops, I would typically say for I in range in the Python language. And what I is the index position. But in this case, they've called it count. So that has to be count. So if the team count, that means basically the position. So Ali is 0, Eve is 1, Ling is 2. is equal to student name, then return true. Does true need to be in speech marks? It doesn't have to be in speech marks, no. So there's another 4 marks. I think that's 57 for us now. Yep, 57 potentially. Might have dropped one on one of those questions earlier. The algorithm calculates the number of points that a student gets for the distance that they throw in the javelin. Complete the trace table, these are easy, for the algorithm when a student in year 10 throws a distance of 14.3. You may not need to use all of the rows in the table. Okay. All you're doing here is you are tracing the algorithm. So you're basically looking at it line by line. So line 1, javelin throw equals input, enter the distance. Line 2, year group equals input, enter the year group. Yeah, so you're basically doing it line by line. So what I'm going to do is I'm going to put line 1, javelin throw equals input, enter the distance. So what do they throw? 14.3. There you go, 14.3. Year group, we haven't entered that yet. Score, no score at the moment. Output, not relevant. So we move on to line 2. Let me put my other ruler up there. So line 2, year group equals input, enter the year group. So line number 2, year group is 11. Score has not been entered. Output is not relevant. So we move down to line 3. Now, line 3 says if javelin throw greater than or equal to 20, which ours isn't, it's under 20. So I'm not going to put the number 3 there. Then score equals 3. Well, no, that doesn't apply to us. Else if javelin throw is greater than or equal to 10, so this does apply to us, score equals 2. So I'm going to leave a gap, and then I'm going to say line 6, score is 2. Okay. Line 7, else, score equals 1. That doesn't apply to us. End if. Line 10, if year group is not equal to 11, then we were in year 11, so score equals score times 2 doesn't apply to us. End if. Print, the score is, and then the actual score. So I'm going to leave a gap again, and I'm going to say line 13. Should I say the score is? Yeah. The score is, and then what is our score? Oh, hold on, I've made a mistake, haven't I? What a stupid. Sorry. Complete the trace table for the algorithm when a student in year 10 throws a distance of 14.3. Good job I spotted that. Because I was just thinking, I remember marking these and the score wasn't 2. 14.3 on line 1, 10 on line 2, sorry about that. The score on line 6 is 2. So let's go back to line 6. So score is 2, yeah? Else, score equals 1, doesn't apply to us. End if. If year group is not equal to 11, right, so this now does apply to us because I was a twit and I put 11 instead of 10. So if year group is not equal to 11, so ours is in year 10, then score is score times 2. So the score gets doubled. I did deliberately leave a line there, but not because I knew I'd make a mistake. Line 11, score is score times 2. Okay, and then line 12, line 13, print the score is, and it should be a number 4. Phew, thank God for that. And this is going on YouTube as well. I would look very stupid, wouldn't I? Okay, so 57 plus 4, 61. I nearly made a meal of that. Let's keep moving. Probably getting towards a grade 7 now with 61 out of 80. In fact, almost definitely already got a grade 7. The height a student jumps in the high jump needs to be input and validated, so it needs to be sort of restricted. The height is entered in centimetres and must be between 40 and 180 inclusive. So we had a question a bit like this earlier, didn't we? Write an algorithm to take the height jumped as an input. So that's easy. Let's do that first. Height equals input. How high did you jump? Question mark. Output valid or not valid depending on the height input. There's 2 ways you can do this, but the way I'm going to do it is what I call the negative way. So I'm going to say if height was less than 40, yeah, or height, what was the upper boundary? Greater than 180, yeah. So if height is less than 40 or height is greater than 180, then I want to print, what do we want to say? We want to say not valid, don't we? Because that's what it says in the question, and they put it in capitals, so I'm going to put it in capitals. Okay, and then else, so anything other than that, and print capital letters, valid. So take the height input, output valid or not valid. Yep, I think that'll do. 4 marks, thank you very much. What's that now, 65 potentially. The algorithm is tested using a range of tests. Complete the table to identify an example of test data for each type of test. So test data is what you would enter to see whether what you've done is correct or not. So normal, what you want is any value between 40 and 180 inclusive. So let's just say 75. Just go for something in between those two values. Boundary is where you want to say either 40 or 180, nothing else. Okay, because you're testing the lower and upper boundaries. And then erroneous, you could put something like banana, because you don't want someone to input banana when the question is how high did you jump? Okay, we're not minions. So 68 so far. SQL, honestly, every single year, there's always a 4-mark SQL question. Every single year, every single student should get 4 out of 4 on those questions, in my opinion. Select student ID, complete the SQL statement to show the student ID and the team name of all students who are in year group 11. So what we're doing with select is we're selecting the data that we want to show. And the question says show the student ID and the team name. So it says select student ID, and then we just need to copy team name in the same format as it is in the table above. So capital T, capital N, nothing else. From, so what is the name of the table? The name of the table is TBL result with a capital T and a capital R. So from TBL result, where, that's probably worth a mark on its own, where all students who are in year group 11, so year group with a capital Y, capital G, so where year group equals 11. Now, I do remember this from the mark scheme. They would give you the mark if you put 2 equal signs there. I disagree with that. I'm talking about here. It should be 1 equal sign only, because that's the SQL syntax, okay? 2 equals, yes, in Python we'd use if we were checking something, but the exam board were obviously very kind this year and would have allowed that if you did that. So I reckon we're on 72 now. Abstraction and decomposition have been used in the design of the Sports Day programme. Identify one way that abstraction has been used in the design of this programme. Abstraction has been used in... right, okay. This question is slightly odd for me, because what we're doing is we're talking about where data has either been ignored or removed so that the focus can be on what's important. So I'm just going to say focus is on event and what else did it take, and team name. Okay, so it doesn't appear that this school have got a house system, or if they do, they're not appearing to use the house system. So it appears that they choose their own name and they're using that. So the focus is on the event and team names. We don't need to know the names of the participants, it seems. Identify one way that decomposition has been used in the design of this program. So in the table, they've got, hang on, what's this asking for? Yeah, see, I find this a slightly tricky question. I think what they're talking about here is that you've got the table fields representing one type of value each time. So I'm going to say, oh no, or is it, hang on a second. The individual results for each student in each event are stored in a database. The database table results shows the times of students in the 100-meter race. Right, sorry, I didn't read that earlier, did I? So it appears that each event has its own table. I'm not 100% sure that that's correct, but I think it's very likely to be. I'm not entirely sure what the question's asking for there, but I think that's what it's asking for. So I'm not gonna add 2 to my score there. Let's just say that I'm still on 72 because I had a question mark earlier and I've got a question mark here. So let's assume that I might have dropped 2 so far. So we've got one question left, and it's a programming question. No, it's not. It's not even a programming question. It's an algorithm question, which you can write in a programming language. Okay. What this is asking for is an algorithm that prompts the user to enter a team name and score, or enter stop to stop entering new team names. So that immediately tells me that there's going to be a while loop here. Okay, so there's going to be a while loop. But what I like to do before I write my while loop is I'll use a variable called high score, which I'm going to set to 0 to begin with. Okay, so that's called initialization. We're going to initialize the high score variable as the value 0. And it says prompt the user to enter a team name and score. So let's say while team, and it stops if they put a stop. So while team is not equal to stop. Okay, so while team is not equal to stop. Team equals input, and then ask them a question here. Okay. What else do we need to enter? We need to enter the score as well. So let's put score equals, I'm going to suggest that score should be an integer input. Score. I know I'm being a bit lazy with that, but I don't think it's going to matter. Okay, and then repeatedly take the team names until they enter stop. So we've done that. We've done that. All right, prompt the user to enter a team. Yeah. So I probably shouldn't have put Q there. Let's put team name. There we go. And then score. Right, okay. So it's going to calculate the highest score. Which team has the highest score? So I'm going to say if score is greater than the one that we set at the start, high score, to 0. So it should be, shouldn't it? If score is greater than high score, then let's change. So score will now be stored in the the value of score will now be stored in the variable, so high score. And then let's have win team equals team. Because if the highest score entered belonged to a team, then the highest score needs to be stored in the variable high score along with the team name that was entered at the same time. All right, so that's not too difficult. I've realized I've made a little bit of an error here because I'm writing Python code, but I haven't put my colons in. So I'm just going to say then at the end of my if and while statements. Right, and then I think all we need to do at the end is print high score, comma, win team. And I think it's that simple. So calculate which teams are the highest score. I've done that. Output the team name and score. Yep. Definitely got at least 5 out of those 6. And I said that we were on 72 on the previous page. So I reckon we've got at least 77 or 78 marks there out of the total of 80. And that is last year's paper 2, 2024's paper 2. Now, I've got my iPad next to me here. Let me just bring up the last year's exam boundaries. 1 second. So 2024 OCR. Oh. Sorry, my internet is not the fastest performing in the world. I probably should have had this ready, shouldn't I? Let me just put that to the side for a moment. So I reckon that we got 77 or 78 out of 80 there. Here we go. It's caught up finally. Let's see what the boundaries were last year for computer science. So on paper 2, so we're looking at this. We're looking at this line here. We'll just put the ruler there, just above the ruler. So to get a grade 9, you needed 71 out of 80. Now that's actually relatively high for a paper 2. I've very rarely seen that, but as you probably noticed from this video, this paper 2 was rather simple and rather straightforward. So you needed about 90% to get a grade 9, which is personally what I believe it should be. but usually it's a lot lower than that. 65 marks or above would have got you a grade 8, and 59 or above would have got you a grade 7. And I'm pretty sure if you're watching this video, you want at least a grade 7. So there we go. That's what you would have needed last year to get those final grades. So I hope you found that helpful. If you have any questions, or if you think I did something different to how you would have done it and you want me to explain it, please put your thoughts down in the comments, and I'll upload paper 1 later this weekend. Good luck, everyone.